Now this brings us to pyrolysis plants, where the waste, the plastic waste, turns into the raw material we want to produce with chemical recycling. And we are very glad that with Carlos Monreal and Chetil Byrne, we have two CEOs of two pyrolysis manufacturers. Carlos Monreal is not only CEO, but also the founder of Plastics Energy and one of the pioneers in the area of pyrolysis. And Chetil Byrne is CEO of Quantafuel, specialized on pyrolysis of mixed plastic waste materials. The two of you have 10 minutes each to give us your input on the importance of chemical recycling for you as pyrolysis plant.
Hello, my name is Carlos Monreal. I'm the CEO of Plastic Energy, and Guten Morgen. I'm going to have to be doing the presentation in English. During my presentations, I'm going to be talking briefly about chemical recycling, the feedstocks and outputs that we have, current plans and the pipeline, LC8 and the environmental data, and example of products. If we can move to the next slide, please. Is why chemical recycling? I would say that we see chemical recycling really as one of the best recycled waste, but it's not a complete solution. It is for us, the chemical recycling can complement mechanical recycling by increasing recyclability of the products and increase virgin quality recycled content for food packaging applications. And at the end of the day, to be able to achieve the targets and commitments that we have as a whole. For us as a company, we understand the difference between mechanical and chemical recycling very well. We just started the business as a mechanical recycling company, and we know the difference and the limitations of what can go to mechanical recycling, what can go to chemical recycling, and what are the challenges with each one of them. Next, please. So who is Plastic Energy? Plastic Energy was founded back in 2011. It is a company that has patented technology that we have been deploying for the last 10 years, and has been the only company that really has validated and certified externally the process of plastics to plastics for a circular economy of plastics. We have very strong partnerships with across the value chain, and that has taken us into a leading position in regards to chemical recycling. Next. Mainly, our mission is focused in 6 areas. But with only one target today, which is to deliver by 2025 at least 300,000 tons of low-grade plastic waste converted into feedstocks for new plastics manufacturing. That's what we call plastics to plastics. That's a global commitment that we have signed with the Ellen MacArthur Foundation that is public, and we really focus all our efforts in delivering those commitments. By reducing pollution, one thing is the situation that we have in Europe, another thing is the situation that we have in Southeast Asia, where they do not have waste management techniques to collect and to sort the waste that is being produced. We try to close the loop on for plastics through by increasing recycling, not only in Europe, but as I said, also in Southeast Asia, and always focusing ourselves in trying to provide high-quality recycled content by virgin food-grade applications, reducing oil dependence and really boosting the economics with new investments. Next. In the feedstocks is something that everybody is constantly talking about. What type of feedstock can be used by mechanical recycling or by chemical recycling, or is chemical recycling the solution for recycling? Well, as I said, chemical recycling is a complementary solution to mechanical recycling. Everything that could be done to recycle plastics mechanically has to go through that route. But there is obviously some limitations to mechanical recycling depending on the type of materials and with the current design of products that have to be improved. But both mechanical has the limitations, but also chemical recycling has the limitations. It's not a complete solution. For us, the type of feedstock that we are processing is we are only focused in post-consumer flexible packaging that is mainly plastic films, multi-layers, and multi-material packaging. The type of materials that are difficult to recycle mechanically today with the current designs. We can also process other type of materials, but however, we are now focused only in post-consumer flexible packaging, where we believe is the main challenge to really increase recycling in Europe or to double from the 5 to 6 million tons per year of recycled plastics to the target of 10 million tons by 2025. The preparation that once that we receive our feedstock, you can see it on the right side, is the plastics coming to us is normally what you called in Germany the 350 type of specs. But the difference is that we do not need to wash the feedstock, the plastics. We do not have to separate it by the polymer type. And we are really focusing in certain type of plastics, almost any type of plastics, except PET and PVC. But can we take any type of contamination levels? Of course not. If we will have, let's say, if in the process we will be working with a more than 40% contamination coming to our technology, the output it will be with qualities that could not be able to be processed later on by the petrochemical companies to produce plastics once again. Or the economics, it will not be very good because there will be only a percentage of the feedstock that will be converted into hydrocarbons, having the same type of operational expenses on running the project. So when we prepare the material, we really try to reduce what we call contamination, and contamination of our feedstock can be from paper, carton, PET, PVC, and certain inks. And over the last few years, we have developed a very amazing and valuable library of what we believe it could really help plastics to become more recyclable, either through mechanical recycling activities or chemical recycling. At the end of the day, what we do for every ton of plastics that we process, we produce about 850 liters of tag oil. That is a mass to volume ratio. If it will be a mass to a mass volume, it will be for every 100 kilos of plastics, we will be producing between 65 to 70 kilos of a liquid product. Next, please. Our technology is a thermal anaerobic conversion. We do not use oxygen in the process. We do not burn anything on the process. It is mainly the main important things is that it is low temperature, low pressure, and very important to remark that this is something people think historically about the high energy consumption of pyrolysis. That is the case, that's the truth. But in our technology, in our solution, we are practically energy neutral in the chemical process because we produce a synthetic gas that we reuse it to heat the plastics during our process. And that make our process could be energy neutral once that we start the chemical process. We have different patents in the European Union and the USA, and mainly the process, as you can see in this diagram, starts with the plastics coming to extruders. In that moment, the extruders melt the plastics. We increase the temperature to less than 300 degrees. Then we take it into a reactor, and since that moment, as I said, the energy is completely neutral. And then we increase the temperature in the reactor to less than 500 degrees, and then we take it into the contactor, then we condense it, and we produce the liquids that we later on sell to the petrochemical companies to use as a feedstock to produce new virgin quality plastics. Next, please. We have two operational plants in the south of Spain. One of them since 2015, the second one since 2017. Currently, our plants are 100% producing taq oil that is being used in 100% of the cases only for food-grade applications, only to produce new plastics. We do not support the plastics to fill alternative, and we are only focused in plastics to plastics concept. The yields, as I was mentioning before, is something like about 72 to 75%. Then we produce the 18% that is the synthetic gas that we use to power the plant and reduce the energy from the external energy. And then we produce also, depending on the contamination of the feedstock coming to our process, something like about 10% of what we call char, which is like a powder carbon that we sell it to the construction industry and energy production. But 100% of our taq oil, which is the majority of the outputs, is now used only for the production of new products. Next. Something very important is that so far we've been listening about the different comments about chemical recycling. And by the way, chemical recycling, I'm only talking about one of the different technologies of chemical recycling. Chemical recycling has different technologies for different type of applications, for different type of materials, but I'm focused only in our process. Many companies recently have raised the challenge of what is the footprint of this type of processes. In our case, we have done an independent LCA, ISO compliant by Quantis, an external company, and the conclusions that we have out of that report is that our process, plastic energy process, has a lower climate change impact than incineration with energy recovery. That's very important to say. Also, that it has a lower climate change impact than virgin plastics, which is something extraordinary and very important for the future of our planet. And the positive thing is that this is only the beginning, because those type of technologies, in our case, only 10 years, but in the next years to come, we can see many improvements to be able to be made in those type of technologies. In our case, particularly, continue improving the energy efficiency in order to even reduce the carbon footprint of our process. I know that there is going to be later on some other presentations about LCA, so I'm not going to extend any further. Some important environmental considerations are that we need to comply with the European Union Industrial Emission Directive. This is not only a plant that somebody built and produce all type of contaminants and take into the atmosphere. We are not, first, we are in Europe, we have to comply with regulations, and in our case, we fully comply with the European Industrial Emission Directive. We also have THEMS. THEMS is a continuous emission monitoring system that we use to control the environmental impact. we ran independent tests, and we continued monitoring our process continuously, able to report to the authorities in a 24/7 basis. Additionally, the output, the pyrolysis salt, they have to be registered within REACH, and that, again, we are the only single company in Europe that is REACH registered. That allows also that the products, the pyrolysis soils that we produce, are managed and in an isolated environmental and strictly controlled conditions. And then something critical, and this is a different type of situation, Europe, not only for chemical recycling, but also for mechanical recycling, we have a challenge about the condition of a status of end of waste. End of waste is clear what has to comply according to the European Union. However, when trying to apply it for the condition of end of waste country by country of Europe, the implementations of the general definition of end of waste is different country by country and can take from 6 months to a 2 years process in order to be able to have this status. And that is not only for chemical recycling, but that's also for mechanical recycling. That is something that authorities really have to try to see how to be able to be more faster in implementing the condition of end of waste status. Next. It's important that this is not a theory. As I say, we've been working since 2015. We have demonstrated the loop, closing the loop. We have produced different food grade. Sorry, I have a problem with my connection. So we have demonstrated the different products. Back in January 2019, it was announced in Davos, different products made out of our pyrolysis soil, tacoil, that through SABIC produced products that they were used by Unilever, Viventions, Walkie Group, and they were all certified by the ISCC+. Also, recently we announced the production of different applications for the Magnum taps and also for Nork, or lately with Tesco and Seal Air to produce the Bradbury's cheese. So those are clearly examples that are right now in the marketplace. If we go to the next page, please. Hello?
The next slide. Go on. We have the next slide.
Yeah.
Please go on.
Yes. So the next slide is, we can see that this is really the target for us, for the company, is to be able to build something like about 10 plants by 2025, with each one of those plants to have at least 20,000 tons per annum production capacity. And if we move to the next one, is in this, you can see the current pipeline of projects with the 2 plants in the south of Spain that we are going to expand, the plant in Seville, another project in Tenerife that is going to be an example of sustainability in an island with limited space to manage the waste, and in this particular case, just producing an output recycled that is going to be used 100% for food grade applications. Projects in France recently announced with the company Total, or in the UK with Feedstock coming from Viridor, in the Netherlands with SABIC, Malaysia, Petronas, or Indonesia in different countries. So those are our commitments, and we have other projects in the pipeline, but reality now our main focus is to deliver the 10 plants by 2025. Thank you very much for your time.
Thank you very much, Carlos. And we have got one question directly to you and one as I said, Verständnisfrage, just a clarification question from Frank Holtrup, Covestro. Hat das Tug Oil eine relativ konstante Zusammensetzung oder
a consistent composition, or does it vary depending on the plastic waste you use?
Yes. Is the plastics is relatively stable. Over the last 5 years, the specs are quite very stable within the same range. But obviously, that is also due because we have clear specifications on the type of feedstock that we want to process. So it has a direct relation with the type of feedstock that you process.